Let's get started on Module 10, Resource Management and Monitoring, Part 2. We are on Lesson 4, Monitoring Resource Utilization. In this section, we ask the question, how hard is the ESXi host working? How hard are the virtual machines working? And what do we do if either one is maxed out? We can measure resource utilization from the inside or from the outside. When we measure it from inside the virtual machine, we use Windows monitoring tools. When we measure it from outside the virtual machine, we use the vSphere client performance monitoring tools. So let's start out with the monitoring tools inside the virtual machine. Let's look at Windows monitoring tools. Well, I think everybody knows Task Manager. Task Manager is on Windows 7 workstations. It's Windows 2012 Server. Task Manager briefly tells you how hard the CPU is working and how much free memory you have. Task Manager is not a terribly sophisticated utility. If we click on Resource Monitor, which is often called Task Manager's big brother, we can see that Resource Monitor is very much like Task Manager in that it shows CPU utilization and memory utilization, but it also shows disk utilization. A third utility is Performance Monitor, which can be found under Server Manager on Windows Server. And Performance Monitor, like Task Manager, tells you how hard your computer is working, but it allows you to measure more variables. It allows you to measure the variables more finely, and it allows you to measure the variables over time. This is considered viewing it from the inside, because these monitoring tools can only show us what's going on from the point of view of this one individual virtual machine. Now, if we use the vSphere client performance monitoring tools, we can look at the entire ESXi host and all virtual machines. So let's use the vSphere client performance monitoring tools to measure CPU, RAM, hard disk, and network utilization. We can measure performance either per ESXi host or per virtual machine. If we go to our vSphere client and we select an ESXi host and we select the performance tab and we select the CPU performance chart, this shows the CPU performance for the entire ESXi host, and you can see it has gotten rather high at this point. That's the entire ESXi host. You could also look at resource utilization per virtual machine. To do that, you go to your ESXi host, but select the tab that says Virtual Machines, and then we can see one virtual machine seems to have slightly higher utilization. So let's go to that virtual machine and then select the tab that says Performance, and then you can see there are a number of default or built-in charts that show what's going on right now in real time. The first chart shows CPU utilization, and you can see that CPU utilization for this virtual machine is pretty high. We could also look at memory utilization, and you can see that the memory utilization for this virtual machine is up and down. If we look at disk utilization, we can see that there was a little bit of disk activity, but there's not much disk activity now. And under network activity, we can say that there is a little bit of network activity. And if we go down to the bottom, to the summary chart, this just shows all the charts we just looked at. It shows that CPU utilization is high, that memory is up and down, and disk utilization is not very high. So the vSphere client performance monitoring tools allow us to measure CPU, RAM, hard disk, and network utilization for an ESXi host or for an individual virtual machine. Identifying bottlenecks. A bottleneck is the thing that is slowing the system down. So if the users say, this system is slow, what we have to do is identify whether or not the problem is the CPU, or whether or not the problem is insufficient RAM, or whether the problem is a slow hard disk, or whether the problem is too much traffic on the network. So let's start out with, is the problem insufficient CPU utilization? Well, the way we can measure that is we can go to a virtual machine. You notice there's a little error message right here on the accounting server. So let's go to the accounting server and select the advanced button. And if we select the CPU utilization chart, we can see that CPU utilization was flat for a little while in this virtual machine, but we can see that right now it is totally maxed out at 100%. It's currently at 92%, and the maximum has been 100%. That's considered high CPU utilization. If the virtual machine is CPU constrained, meaning if the CPUs don't have enough oomph in your virtual machine, then you can allocate more CPUs to that virtual machine. And I know that we've done that before, but let's just review that. To allocate more CPUs to a virtual machine, you would right-click on the virtual machine, click on Edit Settings, and there is the number of CPUs which have been allocated. In this example, just one. If I want, I could assign an additional CPU to this virtual machine. Now, that would only work if the operating system installed supports multiple CPUs, and if the operating system supports hot CPU swapping. But what if all virtual machines are CPU constrained? If all virtual machines are maxed out, well, that implies that the ESXi host is maxed out as well. And if the ESXi host is CPU constrained, then we can, one, either move the virtual machines to a different host, or upgrade the host. Add additional CPUs to the ESXi host, and you know how to do that. All you need to do is add an additional blade. And as you know, a blade is a circuit board with 2 microprocessors and 4 gigs of RAM. So when you add another blade, you are adding 2 CPUs and 4 gigs of RAM. But let's say the problem is not insufficient CPU processing power. Perhaps the problem is insufficient RAM. So let's see if the problem is insufficient RAM. To examine ESXi host memory utilization, we can look at granted, consumed, active, ballooning, and swap. If we select the ESXi host and we go to the Performance tab and we select the Memory drop down to look at the memory chart, we can see that the amount consumed, and we can see that the amount granted. And we will see there is not a significant difference between the two, which means we don't have very much free RAM. The difference between consumed and active tells us how much, between consumed and granted, tells us how much free RAM we have. And I think everybody's familiar with the concept of free RAM, but ballooning may be a new term. Let's look at ballooning. If we look at our chart for memory utilization, okay, you know what consumed is, and you know what granted is, but what is this balloon business mean? Well, if we go to VMware's website, we can see that there is a description of the memory balloon driver, and what it shows is that the memory balloon driver expands and it forces virtual machines out of memory to swap space to make additional space for additional virtual machines. A balloon driver is a piece of software that forces virtual machines to use less RAM. In other words, it pushes existing virtual machines out of RAM. And what it does is it frees up memory for other virtual machines. Ballooning only kicks in when there is insufficient RAM, so we certainly hope that there will not be any ballooning activity. If ballooning activity is high, that indicates an insufficient amount of memory. And if we look at our example right here, we see that in this example, ballooning activity is 0. So that indicates that we are not in the danger threshold when it comes to insufficient RAM. And then the swap file is something that we've discussed before. Swapping is when the ESXi host runs out of memory. If we look at the swap used right here, as you may recall, swapping is when the computer is out of RAM. And if you have more data than the RAM will hold, the data can spill over to the hard disk to what they call a swap file, a .vswp file. And if you don't run out of RAM, swapping never comes into it. Now Windows has this. You probably heard about this in Windows Server. In Windows, this is also known as, aka also known as, paging, and Windows calls it virtual memory, but VMware just calls it a swap file. So if swap file activity is high, that means we're in a danger threshold, and that means we're short on RAM. So if we're short on free RAM, or ballooning is high, or if swapping is high, well, that means we're short on RAM. So if we are short on RAM on the ESXi host, then the question we have to ask is, one virtual machine taking a large amount of memory, or do we just have a large number of virtual machines on that ESXi host? In other words, we're trying to make the decision, do we have one virtual machine, which is a memory hog, which is taking up most of the memory? So to do that, what we do is under the memory chart, we click on Chart Options. And then under Chart Options, we select the ESXi host that we want to look at. We select the servers that we look at. So I'll check off the accounting server and server 1, and I'll check off the variable I want to measure, which is usage, followed by OK. Oops. And I will select the radio button right here that says stacked graph. Previously we've just been using line graph. If we use stacked graph, that will allow us to compare the virtual machines. And if we look at this, we can see that one virtual machine, the accounting server, is taking the overwhelming majority of RAM, and that the other server is hardly taking any RAM at all. So let's go to that virtual machine and let's again look at these key variables. These key variables were true for the ESXi host. These key variables are true for the virtual machine. So if we go into our virtual machine and under Chart Options, select Memory, we can see that in this example, this is the amount of memory that's granted. And you can see that's just about 2 gig. Now if I click on Consume, notice that line jumps down. Let me back up. That line is granted right there, and that is consumed. So in this example right here, there's no problem. The amount consumed isn't anywhere close to the amount granted. The active memory is even lower, so we're certainly not in the danger threshold here, and balloon memory is also 0. So in this particular virtual machine, there is no memory shortage. But if there is a memory shortage, that is to say, if the free RAM is low, and if ballooning is high, and if swapping is high, well, that implies that the virtual machine is memory constrained. And if the virtual machine doesn't have enough memory, well, we just allocate more memory to that virtual machine, which we have already done in this course, but let's do it. To allocate more memory to a virtual machine, we go to the virtual machine, right-click on it, and select Edits. We select Edit Settings. Then under Memory, we previously had 4 gig assigned to this virtual machine. All we have to do is slide up the little slider bar, and that now doubles the amount of RAM which has been allocated to that virtual machine. Memory shortage, host or VM. If one VM is memory constrained, then you can allocate more memory to that one virtual machine. But if all virtual machines are short on memory, that implies that the ESXi host is short on memory, and the solution is add more memory, add another blade to the blade server. If memory is constrained on the ESXi host, you can, 1, move the virtual machines to a different host, or add more RAM to the ESXi host, and if it's a blade server, by adding an additional blade, about $4,000 per blade, then that adds 4 gig of RAM. So if it's not the CPU and it's not RAM and the system is still slow, now we got to figure out, make the decision, is the hard disk the problem? So this is the memory chart. Let's go over to the chart, switch to, and select the drop down and select disk. And this shows our overall disk utilization. Disk utilization was flat for a while, and then it jumped up here. It's not totally maxed out, but it is a little bit high. One of the main variables that we use to measure disk utilization is disk usage. To monitor the hard disk, you can look at disk usage, but to measure it even more finely, that is to determine which disk is the faster disk, or whether or not a disk is overburdened, we measure latency. And there are 2 types of latency. There is the kernel command latency, and when we see the kernel, we mean what's running in the RAM of the ESXi host. And this measures the average amount of time in the VM kernel per SCSI command, not iSCSI, just SCSI command. And that high numbers, greater than 2 to 3 milliseconds, represent either an overworked disk array or an overworked host. The danger threshold for kernel command latency is 2 to 3 milliseconds. Another key variable is the physical device command latency. This is the average time the physical device takes to complete a SCSI command. The physical device, meaning the hard disk or disk array. High numbers, that is greater than 15 to 20 milliseconds, represent a slow or overworked disk array. The danger threshold for physical device command latency is 15 to 20 milliseconds. So let's add the latency counters. To add the latency counters, okay, we already have disk usage there. We go into chart options and we click on chart options, and we click off on the checkbox for kernel command latency, and we click on the checkbox for physical device command latency, and of course we want to leave the checkbox for usage already checked off. Click on OK. Now this shows us kernel command latency and physical device command latency. Now the danger threshold for physical device command latency is 15 to 20 milliseconds, and you can see we're not coming anywhere close to that. That's not a problem. But if we look at kernel command latency, the danger threshold there is 2 to 3 milliseconds, and look, we've got 20 to 30 milliseconds there. So this implies that either the ESXi host is dragging and it can't push the data out fast enough, or it implies that the disk array is not a powerful enough disk array and cannot take the data in fast enough. And of course, there is a variable for usage as well. So when we monitor the hard disk, we look at disk utilization and we look at latency, kernel command latency and physical device latency. So if disk utilization is high and the danger thresholds have been exceeded for latency, well, that means the disks are constrained. So what can you do if the disks are constrained? One thing you can do is you can move the virtual machine disk files to a different data store, perhaps a faster data store. Or you can implement disk striping on the disk array, and this course really doesn't cover disk striping, but disk striping is where the operating system writes to two hard disks at the same time. They call that RAID level 0, and another type of striping is called RAID level 5. Don't confuse it with RAID level 1, that's disk mirroring, and that doesn't make things any faster. Or you can get faster hard disks. SATA hard drives are commonly used, but you might want to upgrade to SAS hard drives, serial attached storage. The spindles spin faster. Of course, they cost more. Or you can implement network interface card teaming on the storage area network to double the throughput, or you could upgrade the storage area network technology from ESXi to fiber channel, and well, that ain't cheap. So if it's not the CPU and it's not RAM and it's not the hard disk, but the users are still complaining that the system is slow, now we have to ask the question, is the system slow because of excessive network traffic? Let's look at some of the different methods of measuring network activity. If you go in Task Manager and you click on the Networking tab, it shows you how the activity that is on the individual network interface card for just one individual virtual machine. If you use a network monitor or a protocol analyzer such as Sniffer or Wireshark, it can show you overall traffic on the network segment, and you can see traffic is about 50% here, and then it blasts up to 100% and it drops off. So this is kind of high traffic right here. It's kind of pushing it. And another program is called IO meter, which is also called iometer, and that allows us to measure the traffic of various virtual machines on the virtual switch within the ESXi host, and allows us to determine if one virtual machine is taking a disproportionate amount of network bandwidth utilization. Now let's look at the vSphere client to measure network activity. So we go to the ESXi host and we select the Performance tab, and we select the drop down to select network. And this shows the amount of network activity on the virtual switch in our ESXi host, and you can see it's not really a problem now. There doesn't seem to be a lot of traffic. If network utilization is high, that is to say, if bandwidth is constrained, there are a couple of things we can do. One is verify that VMware tools is installed on each virtual machine, and we should have done that from the get-go. We can implement bandwidth throttling, which we looked at in the chapter on virtual switches. We could create separate virtual networks to segment traffic. We could add a second network interface card and implement NIC teaming, or we could upgrade our network technology from ESXi to fiber channel. Performance optimization and monitoring. Performance monitoring means looking, and optimization means taking action. If you saw that CPU utilization was 5%, that's called performance monitoring. If it's 5%, that's not a problem, so you wouldn't do anything. But if you saw that processor utilization was 95%, that's called monitoring. And therefore you would do something about it, and that is called optimization. Monitoring is looking, and optimization is taking action. So in general, we have three general variables which we measure, and each variable has a danger threshold, and then there is an action that we might take to satisfy that danger threshold. For example, if CPU utilization is greater than 85%, that is considered a danger threshold. I mean, I don't mean it occasionally spikes to 85%. I mean it's sitting at 85 and 95% all day long. If that's so, you could get a faster CPU, or get a dual-core processor, or a quad-core processor, or get multiple processors, or maybe even move some of the virtual machines to a different ESXi host. Free RAM, which is the difference between granted memory and consumed memory. And if free RAM is less than 15%, that's a danger threshold. I mean, the system will still run on 10%, but that's just getting a little too low. Typically, we consider 15% to be the danger threshold. If free memory is low, then we can, one, simply get more memory. Or we can uninstall some of the virtual machines and install them in other ESXi hosts. If disk utilization is excessively high, I don't mean an occasional spike, but I mean it's high all day long, then we can get a faster hard disk. We can upgrade from SATA to SCSI, or maybe even serial attached storage. We can also implement disk striping, which is called RAID level 0, where both the operating system writes to two hard disks at the same time. But this is something that we would configure on the disk array. We do not cover that in this class. And if network utilization is high, and the danger threshold for network utilization is when it starts to get above 50% is when we start to worry. And if network utilization is high, then you might want to get a faster network. That is, upgrade from 1 gigabit Ethernet to 10 gigabit Ethernet. Or you could get a second network interface card and implement NIC teaming, and that would take you from 1 gigabit to 2 gigabits of throughput. Danger thresholds can be expressed as absolute numbers or as a deviation from the baseline. Notice the danger threshold for CPU utilization is 85%. If it's 85%, then worry about it. If it's less than 85%, well, then don't do anything. At least that's what's meant by danger thresholds by absolute numbers. But that's not the only way to identify danger thresholds. Another way of calculating danger thresholds is observing deviation from the baseline. Now, a baseline shows average utilization over time. So if we look at this baseline of CPU utilization, we can see that the average utilization, January, February, March, April, is about 20%. The average CPU utilization is 20%. That's called a baseline. So suppose that we see that one day CPU utilization has gone to 60%. This is called deviation from the baseline. Now, you might say, well, 60% is not a danger threshold. 85% is a danger threshold, so don't do anything. But wait a minute. If CPU utilization has been 20% day after day, week after week, month after month, and one day it triples, that implies that something is wrong. A virus, bad hardware. I really doubt if the number of employees and the amount of equipment has tripled in one day. So a danger threshold can be an absolute number, but another danger threshold is deviation from the baseline, and this is just a perfect example here. The baseline is 20. If utilization triples, to 60, even though 60 is not 85%, that kind of a deviation from a baseline indicates something's wrong. Danger threshold could be an absolute number or a deviation from the baseline. In Lab 17, you will use the vSphere client to monitor CPU and memory utilization for the entire ESXi host. And then you'll use the vSphere client to monitor CPU and memory utilization for an individual virtual machine. And then do something to generate activity on the ESXi host just to push the numbers up to see if you can get some activity out of those counters. Let's now go to lesson 5, using alarms. Throughout this course, you may have noticed all kinds of alarms have been going off on the ESXi hosts and on the virtual machines. Yellow is a warning, red is an alarm. And we will see that there is an alarm right here. An alarm is a notification that occurs in response to a selected event or condition that occurs with an object in the inventory. Default alarms exist for various inventory objects. So if I go over to my data center, I can see there is an error message on that ESXi host. So let's go to that ESXi host with a little red diamond on it. And if I click on the tab that says alarms, it says there's an alarm, something about the vSphere high availability host status. We'll cover that later in the course. So what the heck is the vSphere high availability host status? That's the triggered alarm. If we look at the definitions, we can see that the vSphere high availability host status is the default alarm to monitor the health of a host as reported by the vSphere high availability service. Here's another example. Host memory utilization. This is the default alarm to monitor host memory usage. There are multiple built-in alarms. Let's take a look at the host memory utilization alarm. If we click on Edit Settings, we can see the name of the alarm is host memory usage, and this alarm currently is enabled. If we look at triggers, we can see that if host utilization is above 90% for 5 minutes, then the system will show a yellow warning message. But if that condition continues, and then we get 95% utilization for another 5 minutes, then it will show a red diamond, which is not a warning, it is an error message. Let's look at creating our own alarm. To create an alarm, we right-click on the side of the screen and select New Alarm, and I'll give the alarm a name such as High CPU Utilization. This alarm will monitor not data stores, but simply virtual machines, and it will monitor for specific conditions or state, for example, CPU utilization. It could monitor for specific events, such as a virtual machine being powered on, but we'll leave it for a specific state. Now let's look at triggers. Let's add a trigger. You can click on Add Trigger or just right-click in the middle of the screen and select Add Trigger. And this trigger will be called Virtual Machine CPU Utilization. And here's how we will configure it. We will configure it such that if virtual machine CPU utilization is above a certain amount, such as 75%, for a certain period of time, such as 5 minutes, then it will show a yellow warning message. However, if that continues to the point whereby processor utilization gets to be 90% for 5 minutes, then that will show a red diamond, which is an error message. If we look at the Actions tab, we can see that we can send a notification trap, which is something associated with the simple network management protocol, or we can have the system send an email. I mean, it'll show an error message on the screen on the ESXi host, but if we like, we can have it configured to send the network administrator an email. Let's do something to trigger that alarm. There's the alarm, the high CPU utilization alarm. So let's do something to trigger that alarm, just to test it out. One thing we could do is bring up the calculator and calculate the square root of pi. That might do it. Or another thing we could do is go into the virtual machine and go to the command prompt, and from the root of the C drive type dir space C:/S, and that will show a long listing of all the files on the computer, and that will push up processor utilization and disk utilization as well. After we've done those two things, if we come back to the ESXi host, we can see that an error message has been triggered indicating that CPU utilization is over 90%. I've seen the error message. I can now right-click on the error message to clear the error message to indicate that I've already seen it. In this lab, you will, 1, create a virtual machine alarm that monitors for a condition, such as CPU utilization greater than 95%. Then, create a virtual machine alarm that monitors for an event, such as bringing up a virtual machine. And then do something to trigger the virtual machine alarms, and then acknowledge the alarm by right-clicking and selecting Acknowledge. And then lastly, disable the virtual machine alarms. In summary, in this module we have discussed virtual CPU and memory concepts. We discussed establishing resource controls such as shares, limitations, reservations, and we saw those shares, limitations, and reservations can be applied to a single virtual machine, or they can be applied to a resource pool, which is simply a group of virtual machines. We can use the performance chart to monitor resource utilization to determine when CPUs are maxed out or when memory is maxed out, and we can use alarms to alert us when certain conditions or events occur. And this concludes Module 10, Resource Management and Monitoring. Thank you very much, and have a nice day.